My name is Qi Wen. I'm from the physics department. In the next couple of minutes, I'm going to show you how a physicist can try to identify cancer cells and study for the pain in the neural system. My lab is essentially using the mechanical test on the cells. Basically, we're dealing with the issues related to the cancers. We know that cancer is a worldwide health problem. It's one of, I think it's the second leading cause of death in the world, just shy of the cardiac vascular diseases. And also, each year, there's more and more new patients has been diagnosed of cancer. And because of this deadly disease, and more people getting affected, then there's an immense effort in researching for new and effective treatment for the cancers. And we know that there's a CT, there's immunotherapy, and a lot of other treatments over there. The new technologies has been developed in the recent years. And many cancers, some of them, they can be cured. But all these techniques, they rely on the early detection of the cancer. The early we can detect the cancer, the easier to treat them. And it's often, if you detect it too late, then the treatment is not that effective anymore. So we need early detections, especially if we can detect the current technology in detecting the cancer is based on the CT and elastomographies and also the MRIs. What it relates to, you have to see the tumor. The tumor forms have a larger mass. They have a much stiffer touches over there. For example, the breast tumors, the patient, they can touch their tissue, they can feel the lumps over there, right? But all these detection techniques, they rely on the formation of a tumor. If we can detect this cancer at the cellular level before it forms a tumor mass, it will kill the cancer in infancy. And so also, another issue with the cancer is that there's a significant pain over there. And that deteriorates the quality of life for the cancer patients. And these pains are related to basically the pressure from the tumor, and also the chemotherapy and other therapies can damage the neurons. We don't know what the mechanism behind it yet. I'm going to show you what we can do to study this mechanism of the neuropathic pain. So in order to identify cancer cells, we have to find out some parameters that can differentiate the cancer cells from normal cells. And I'm not a biologist, I'm a physicist. I know how to apply forces and how to measure deformations. I don't know how to run the Page gels. I don't know how to do the PCR yet. The good thing is that in addition to the other biological changes in the cancer cells, there is also a mechanical changes in the cells. And in the past few years, my lab measured these brain tumor cells. We found that the normal cells are much stiffer than the cancer cells. What it means that if you think about squishiness, the cancer cells are easier to be squeezed. And I'm sorry that this is so technical here. You can see the numbers, but this numbers is basically the Young's modules indicating how soft are they. To give you an idea about what these numbers mean, if you see these cells which is smaller than 1,000 Pascal, then that means they are as soft as the soft tofu. You can get over there. Many of you touch that. And if you see the cells are stiffer than around like 4,000 Pascals, they're on the order of, say, the marshmallows. We do this on the summer camps. That's good. We can have a parameter that can differentiate cells from the normal cells, cancer cells from normal cells. But before we can measure it reliably, we have to take a look at these measurements are usually affected by the measurement conditions. To measure the cells, we put them on some materials that will poke on the cells. And then what we see is that these cells, like us, if we're sitting on different materials, we feel a different thing there. The cells can sense the underlying material, the roughness. If you sit on a needle, you feel pain. And if you sit on a soft couch, you feel comfortable. Cells can sense the same thing. If they face a different environment, they will adjust their stiffness to make them stiffer or softer. They can even change the relative stiffness of the normal and cancer cells. On some conditions, you can see the normal cells will be stiffer than the stiffer than cancer cells, and some conditions, the cancer cells will become stiffer than the normal cells. Same thing for the inside the cells. There's a polymer network. Look at spaghetti, and when I was a postdoc, I measured the mechanical properties of the spaghetti network. They are not like rubbers. the more you deform it, the more it will look stiffer. So that's indicating if you measure it not carefully, take a larger deformation, the cells will appear stiffer. So in order to avoid these issues, collaborate with a mechanical engineering group and from UMass Medical School, UMass Law and mechanical engineering. We use optical chopsticks to hold the cells. The optical chopsticks, just like as a chopstick, we can grab the cell like we grab the sushi, and then we put them free of the substrate effects. Then we can image the cells vibrating freely. Then we can measure its stiffness. And the second project we look at neuron pain is that the pain is essentially it's affecting the neurons inside it. To look at the mechanism behind it, we use a very tiny needle to apply controlled force at specific locations to measure the mechanical sensitivity of the neurons. Then we can look at whether it's the injured neurons to induce this pain, or it's the surrounding neurons are really inducing this excessive pain. Thank you.